Hello everyone, I welcome you all to my channel. Today we are going to continue from the very topic which we left unfinished in our previous video. So today we are going to finish understanding basic terms which are used in computer network. So let us begin with that now. We learned about some basic terms like line configuration, topology, and transmission modes, and in this video we are going to get an in-depth understanding about these terms. So let's continue with our first topic, which is line configuration. Configuration can basically be explained as how the devices are connected to each other via a link. A link is a transmission path through which data is transferred between two or more devices. A device can be a computer, printer, or any other device capable of sending or receiving data from the other node device through the network. LAN configuration can be of two types. First is point-to-point and the second one is multi-point configuration. So, talking about point-to-point configuration. Point-to-point configuration provides a dedicated link between two devices. In most point-to-point connection, actual length of wire or cable is used to connect two devices. Examples of point-to-point connections include of an infrared remote to change the TV channel or the Bluetooth connection between your phone and Bluetooth headset. Now coming to multi-point configuration. A multi-point connection is one in which more than two specific devices share a single link. They share it specially. On the other hand, many users are using the same link by turn. It is a timeshare connection. So, as you can see here, the main link is between device A and device B. The other devices here, for example C and D, are also sharing the same link which is between A and B. But what will happen here is when data transfer between A and device B will be going on, then no other devices, for example C or D, will be able to share to anyone. Okay. And only when the data transfer will be finished, the devices C or D will be able to transmit the data to any other devices. Okay. Moving on to our next topic, that is topology. Network topology refers to the arrangement of different elements like nodes, links, or devices in a computer network. Common types of network topology include bus, star, ring, mesh, and tree topologies, each with its advantages and disadvantages. So let's pick our first topology, that is mesh topology. In a mesh topology, devices are interconnected with multiple paths for data to travel. This can be full mesh, that is, every device connected to every other device, or partial mesh, that is, some devices connected to multiple others. Advantages of mesh topology is it is highly reliable and it has high redundancy. Second advantage is even if one link fails, data can travel via another route. Now coming to disadvantages, we have it is expensive due to large number of connections. As you can see here, every node is connected to every other node via a cable or any other medium. So the cost of cable makes it very much expensive. Second disadvantage is that it is complex to install and maintain. Again, due to it, because it has many cables and connections, it is complex to maintain. And now moving on to our next topology, we have star topology. In star topology, each device has a dedicated point-to-point connection only to a central controller, which can be a hub or a switch. The hub acts as a repeater for data flow. Each device has a dedicated connection to the hub. Here you can see every node in this topology is connected to a central controller, that is hub. You can see here it this central controller can be a hub or a switch. It depends on the requirement of the network. Okay, so talking about advantages of this topology is that it is easy to install and manage. Second one is one node's failure does not affect the rest of the network. Okay, now coming to the disadvantages, they are it requires more cable than bus topology. About bus topology we will study in next slide. Second disadvantage is if the central hub fails, that is this device, if the central controller fails, the entire network is affected because the central controller controls the whole topology and data flow in the network. The third and the last disadvantage is it is more expensive due to the cost of hubs or switches. The central controller is usually the very expensive thing in this network. So this becomes a disadvantage for the star topology. Now moving on to our next topology, we have bus topology. In bus topology, all the devices are connected to a single central cable known as backbone or bus. Data sent from a device travels along this central line until it reaches its destination. It is mandatory to install a terminator at each end of the bus to ensure that the data does not get corrupted or distorted, as the data may reflect if we don't install the terminators. Okay, now talking about the advantages of bus topology, we have it is easy to install and extend, and it requires less cable than star topology. Now talking about disadvantages, we have it is difficult to troubleshoot, and second is if the main cable, that is this bus, fails, the entire network will go down. And the third one is limited cable length and number of nodes. So we have limited cable here, and the number of nodes we can connect to this cable is also limited. Okay, now moving on to our next topology, we have the ring topology. Topology, each device is connected to two other devices forming a ring. Data travels in one direction, reducing the chances of collision. Each device has exactly two neighbors for communication purposes. Like you can see here, if we take this node, it has two neighbors. First is this and the second one is this. Same is the case with all the other nodes. So the chances of collision in this type of topology is very less, because the data will travel only in one direction. Like if these nodes wants to share data to this node, the data will either go from this direction only or this direction only. So let us take example that data will travel through this direction, so it will go through this node and then this node, and then finally it will reach its destination here. Okay, the data will not flow from this direction. Okay, so this will reduce the chances of collision in this network. So now let's talk about the advantages of ring topology. First, we have data transmission is relatively straightforward. As we said, the transfer of data will be in unidirection, so the transmission is relatively straightforward. Second one we have is that performance is better than bus topology under heavy loads. Now talking about disadvantages, we have a failure in any cable or device can disrupt the entire network. Second disadvantage is that network configuration can be complex. Okay. Now moving on to our next topic, which is transmission medium. Transmission mode refers to how data is transmitted between devices in a communication network. It defines the direction of data flow. There are two primary transmission modes. First is simplex and second one is duplex. Duplex is further divided into two types, which are half duplex and full duplex. So let's explain what simplex is. In simplex mode of transmission, data flow in one direction only, from the sender to the receiver. The receiver cannot send back data to the sender. As you can see here, the device which we are currently taking is computer, that is CPU, and a monitor. So you have seen that a CPU only sends video signal to the monitor and the monitor just displays it to the user. Okay, the monitor does not send any kind of signal back to the CPU. So this is a kind of example of simplex mode of transmission. Characteristics of the simplex transmission mode are: first, it is unidirectional. Communication can be done only in one direction, that is from sender to the receiver. Examples can be included as keyboard and monitors. When two type, the keyboard sends data to the computer, but the computer does not send back any kind of data to the keyboard. Use cases are broadcast systems like television and radio, where information is sent from the station to the audio without any return signal. Now let's talk about the advantages of simplex mode of communication. First is that it is easy to implement and simple to maintain. Second one is it is suitable for scenarios where communication is only needed in one direction. Now let's talk about disadvantages of simplex mode of transmission. There is only one disadvantage, that is no two-way communication, limited interaction. That is not needed here, by the way. So this becomes its disadvantage. Now in duplex mode of data transmission, we are studying half duplex mode. So data can flow in both directions in half duplex mode, but not simultaneously. When one device sends data, the other must wait for the transmission to complete before sending data back. Okay, so here you can see that when device 1 sends a data at time 1, the device 2 stays stationary and does not send any kind of data. When the data transfer gets completed, then only the device 2 will send any kind of data, which can be any acknowledgement or another data. It can be anything. Okay. Now the characteristics of this kind of network is that it is bidirectional but not simultaneously. Like we just said that both the device can communicate with each other, like send message to each other, but not at the same time. Okay, devices take turns sending and receiving data. Examples can include walkie-talkie. Okay, when one device sends any audio message, then other device just receives it and listens to the uh, data. When the data transfer is over, then only the second device will send the data back. One person talks while the other listens. They cannot talk simultaneously. Basically it is the what happens in a walkie-talkie. Use cases of half duplexes in CB radios, point to point communication systems, where simultaneous communication is not required. Now talking about advantages of half duplex is it is efficient to use of the communication channel, like efficient to use of the communication channel. Second advantage is reduce the chances of data collisions since only one device transmits at a time. Now talking about disadvantages, we have communication can be slower due to the need for device to take turns. Okay, it can take many hours to transfer a single file from device 1 to device 2 and then device 2 to device 1. So it can take a lot of hours. This is the main drawback of half duplex. Now, talking about full duplex. So just correct it here. It is full duplex. Okay. In full duplex mode, data can flow in both directions simultaneously, allowing for two-way communication at the same time. So what happens here, that data from device 1 and device 2 can be transmitted to each other simultaneously at the same time. This is the main advantage of full duplex communication. Characteristics include that first is bidirectional simultaneously. What happens in that is both the devices can send and receive data at the same time, which I just explained. And example devices can include telephones. Both parties can talk and listen simultaneously. When you call your friend, you can also speak to him and he can also speak to you at the same time. It is full duplex communication. Use cases of full duplex are in modern computer networks, Ethernet connections, and internet communications, where real-time exchange of data is crucial. Now talking about advantages of full duplexes, it is ideal for applications requiring real-time exchange of data. Disadvantage of full duplexes, it is more complex and expensive to implement due to the need of simultaneous transmission and reception capabilities. Okay, it becomes more expensive to deploy the technology of simultaneous transmission as well as the receivement of data. So this is the end of my presentation. If you liked my presentation, please hit the like button and subscribe to my channel. Also tell me about what you liked in the video, and also tell me how can I improve my work in the next video. Thank you very much. Also please do subscribe to this channel.